Section 2.4 is writing equations of lines. We do those so you can model a steady increase or decrease. We write equations of lines to find parallel and perpendicular lines, and some other great things like that. To start off with, writing an equation of a line given a slope m and a y-intercept b, we're going to use the slope-intercept form, y equals mx plus b, which we just learned in section 2.3. If I want to write an equation of the line that has the given slope and y-intercept, again, remember our slope-intercept form, if they tell us that m is 3 and b is 1, it's really just a matter of plugging in to this formula right here. So I'm going to write this as y equals m is 3, x, and b is positive 1, so it'll be plus 1. Next up, m equals negative 2, b equals negative 4. To write that equation, it would be y equals m is negative 2, so it would be negative 2x. And this time b is negative 4, so I'm going to write minus 4. And then for this last one, y equals, my slope is negative 3/4, so it'd be negative 3/4 x. And b is positive 7/2, so I'm going to go plus 7/2. And that's how you'd write an equation given m and b. What about writing an equation of a line given a slope m and a point? We're going to call this point x1, y1. You use what we call the point slope form. The point slope form is y minus y1 equals m times the quantity of x minus x1. In this example, we're going to write an equation of the line that passes through the point 3, negative 1 and has the slope of negative 3. So if you remember, the equation that we just talked about was y minus y1 equals m times x minus x1. I'm going to label this point x1, y1. Now it's just a matter of plugging in. This first y is going to stay y. So it'll be y minus y1 is negative 1. So I'm going to put that in parentheses. Equals m is negative 3 times this x stays the way it is, so it'd be x minus, and x1 over here is positive 3. So I'm just going to write 3 down there. Now when we finish this answer, we always want it to be in slope-intercept form at the end. So we do need to solve for y. So the next step would be to go ahead and change these signs to plus positive. So this becomes y plus 1 equals, now we distribute, negative 3 times x is negative 3x. And here you need to watch the signs. Negative 3 times negative 3 is plus 9. Then to get y by itself, I need to subtract that 1. So we subtract the 1 from both sides. Make sure you line up the constants. So then these are going to cancel each other out, which is what we wanted because we want y by itself. So now y equals negative 3x, and then positive 9 minus 1 is plus 8. So that completes that problem. We have written an equation and we've finished it in slope-intercept form. What about if we have 2 points? Write an equation given the 2 points x1, y1 and x2, y2. First step is find the slope. Remember the slope formula is y2 minus y1 over x2 minus x1. And then the second part is to use the point slope formula that we just learned with the slope and either of the 2 given points. To do an example, I've got the points negative 1, 3 and 2, 9. The first step is to find the slope. So I'm going to start with that. if I want to find the slope, we learned this a couple sections ago. We take y2 minus y1. So it's going to be 9 minus 3 over x2 minus x1. So it's going to be, in this situation, 2 minus negative 1. Now if I solve those, 9 minus 3 is 6. And again, down here we change minus a negative to plus positive. 2 plus 1 is 3. So now my slope is 2. Okay, so I'm going to use that slope to plug into this point slope formula that I have over here. Okay, now you get to decide. It doesn't matter which of these 2 points that you use because they both fall on the line. So you can pick whichever one you want. I'm going to use this point right here. Now, because I'm using that point, I have to think of this like x1, y1 when I plug into this point slope formula. So if I move over here and plug into the point slope formula, it's going to be y minus, this y1 is 9, equals, my slope I found out was 2, times x minus, and since I use this point, I need to use this 2 for my x1. So now to solve this, we go y minus 9 equals, distribute, you're going to have 2x. 2 times negative 2 is minus 4. And then I have to add 9 to both sides. So these are going to cancel out. That leaves me with y equals 2x, and that becomes plus 5. So now I've written an equation given 2 points. Now I want to write an equation of a line that passes through the point negative 2, 1 and is perpendicular to the line y equals negative 3x plus 1. The first thing you need to do is look at this equation. The slope of this equation is negative 3. Now you need to think back to what we know about perpendicular lines and their slopes. We learned that perpendicular lines have opposite reciprocal slopes. So for my new line, I have to use a slope that is the opposite reciprocal of negative 3. And remember, it's going to be the opposite, so it's going to be positive, and the reciprocal of 3 is 1/3. Because remember, 3 is like 3 over 1, so the reciprocal would be 1/3. So this is the slope that I need to use, because that's going to be perpendicular to this line. So now I've got a slope. Slope is 1/3, and I'm going to use the point negative 2, 1. That's my x1, y1. And I'm going to plug into the point slope formula just like I did the last couple problems. So it's going to be y minus 1, that's where my 1 came from, equals, my slope is 1/3, times x minus negative 2. And that's where my negative 2 came from. So now I'm going to go ahead and continue to work this out. We want to get y by itself. So y minus 1 equals, I'm going to go ahead and change these signs real quick. So now when I distribute, 1/3 times x is 1/3 x, and then 1/3 times positive 2 is plus 2/3. So then the last part is to go ahead and add 1 to both sides. So I'm going to end up with y, those cancel out, equals 1/3 x. Now I've got 2/3 plus 1. And we want to get out of the habit of writing 1 and 2/3. So what I'd like you to do is actually add those up, and then you're going to write it as a fraction. Now if you remember, 2/3 plus 1. 1 is the same thing as 3/3. That'll give me my common denominator. So I've got 2/3, that's there, and then 1 is also known as 3/3. So now if I add that up, that's going to give me 5/3. So over here is going to be 5/3. because of the 1 plus 2/3. So now I've solved for y. I've gotten y by itself. Next up, we're going to write an equation of the line that passes through -2, 1, but is parallel to the line y equals -3x plus 1. So again, I'm going to go back to this equation. We know that the slope of that line is -3. And then thinking back to what we learned about parallel lines have the same slope. So that means I'm actually going to use this slope. Because of the parallel lines, it's going to have the exact same slope. So again, if my point is -2, 1, that's going to be my x1, y1, and I'm going to use a slope of -3. So to plug in, y minus 1 equals, my slope is -3 times x minus -2. Continue, y minus 1 equals, and again, I'm going to change these signs real quick. So now I have -3 times x is -3x. And -3 times +2 is -6. Now I'm going to add 1 to both sides. Make sure you line the constants up. So then we've got y. These cancel out, so y equals, which is exactly what we want. And then we bring down the -3x. And then -6 plus 1 is -5. So now we've written an equation that was parallel to the line that they gave us from the beginning. And this concludes section 2.4.